Welcome one more time. Snow Day, part deux. We have some homework to go through. Here we go. Um, this was 9 through 30 by threes, A only, part A only. All right, so 9A, here's the drawing. It's in quadrant one. Sign is Oscar had. So then I did the Pythagorean theorem to get the 4. There's sine 2a, there's cosine 2a, and then there's tangent 2a, and all I did was put yellow over yellow, sine over cosine. The 25s cancel out, and the answer is 7/24. I'm moving on. You can pause the video. 12a, here we go. So tangent in quadrant 3 is 4/3. So here's the angle. Tangent is of apples. But there's something way wrong with this because it's going left and it's going down. Oh, tricky, tricky. So this is really -4 over -3, but they canceled out. This is still 5, 3, 4, 5, right? Okay, so that means that sine of angle A or red dot or whatever is going to be -4/5. Cosine of angle A is going to be -3/5. And then that means sine 2A is going to be 2 sine cosine 24/25. Wait a second. Wait a wait a second. What? That's crazy. Now let's do cosine 2A. What did I use on the previous one? 1 minus 2 sine squared. Okay, let's do it again. 1 minus 2 sine squared. 1 minus 2 sine squared. So that's going to be 25/25 minus 2 times 16/25. And that's 25/25 minus 32/25, which is -7/25. Wait a second. Wait a second. Oh, this one's negative. Big deal. And then if I scroll, tangent 2A is going to be sine over cosine, so it's going to be 24 over -7. Ta-da! I'm moving on. You're pressing pause. Here I go. 15A. Okay, so it's in quadrant tres. Oh, these two different color greens really don't make me happy. All right, cosecant. That's the flip of sine, right? So that means the sine of A is 1 over -3. Oscar had. But we know that that hypotenuse can't be negative. So it's really -1 over 3. Okay, so that's the sine of this dot. So the sine is Oscar had. So then you have to do the Pythagorean theorem. -1 squared plus x squared, sure, equals 3 squared. So it's going to be 1 plus x squared equals 9. X squared equals 8. X is 2√2. -2√2 because it's going to the left. Tricky, tricky, tricky. Okay, here we go. Sine 2A. Should have changed colors. 2 sine cosine. Negative and negative, positive, so that's going to be 4 square root of 2 over 9er. Now let's do cosine 2A. 1 minus, you want to do You want to do this one still? 1 minus 2 sine squared? Okay. 1 minus 2 sine squared. So that's going to be a 9, right? So this is going to be 9/9. Dang it. It's going to be 9/9 minus 2 times 1/9. So it's 9/9 minus 2/9, which is 7/9. And tangent 2a is going to be what? 4 root 2 over 7. Hang on a second. Don't worry, I'm back. Okay, so there's that. Let's move on. Once somebody finds out you're at the school, everybody else is like, hey, could you do this and that? Solve for x, general solution. We did one of these. I'm going to turn this into 2 times 2 sine x cosine x, negative square root of 2, divide by 2, and I got 2 sine x cosine x equals negative square root of 2 over 2. Well, this is sine 2x, negative square root of 2 over 2. So now you're going to do inverse sine on both sides. So that makes this side just 2x. And I'm going to do the inverse sine of that. So now I have to get out my note card. And I'm looking up negative square root of 2 over 2 in the sine column. 225. But wait, this is in radians. 5 pi over 4. And 315, 7 pi over 4. Oh no, it's in radians because it said x, not theta. Then divide, and that's 5 pi over 8 and 7 pi over 8. Ta-da! If it would have been theta, it would have been degrees, but since it's x, it's radians. Ready? You can press pause. I'm moving on. Boom. Hey, doesn't this look like a whole bunch of stuff that we've written down for, yeah, tangent 2x equals square root of 3? Well, yes, it does. But now I'm going to do tangent inverse of both sides. Well, this side's just 2x. But now I have to do note card here. And so on the note card, I am looking for square root of 3 in the tangent column, and it shows up at pi over 3. And it shows up at, and by the way, I do not have my glasses again. That was bad. Square root of 3 and, come on, 4 pi over 3. So then I divide by 2 and get pi over 6 and 4 pi over 6, which becomes 2 pi over 3. I'm moving on. You can press pause and switching. Number 24, I think that was supposed to say secant 2x. We skipped it. Oh, all right. So we skipped it. Big deal. Number 27, what in the tartar sauce is going on here? How can I do this problem? Did it really have an equal sign? If it had an equal sign, it's all good, right? Oh, no, it didn't have an equal sign. My bad. It's supposed to have an arrow like this. Okay, you know how there's 3 properties for cosine 2 theta? Well, I'm going to pick the one that I think can factor. So the one that I think can factor would be cosine squared d minus sine squared d all over cosine d minus sine d, because the top factors into cosine plus sine and cosine minus sine. Oh, look at that handwriting. Dang it, that was terrible. I can't do that to you, can I? I guess I could. Cosine plus sine and cosine minus sine. Ah, dang it. Come on. If anything, this video is entertaining to watch me mess up. And then these puppies go, bye, bye, bye. 3-dot boom. There you go. There's the 3-dot boom. Last one, thank goodness. Oh, wow. These notes are from 2018. My handwriting has gotten so much better. Last problem of 2018. By the way, that just shows you how far behind we are from 2018 to this year as far as material learned, because we did this before Christmas break 2018, and here we are almost Valentine's Day. Wow. Wow is right. Wowza. All right, number 30. Now this time it has an equal sign, I think. At least I wrote an equal sign. So I'm going to change the right side first. My goal is to try to get this puppy into sine over cosine, because if I can get the sine and cosine, I get tangent, right? So here we go. I think I'm going to rewrite sine 2y as 2 sine y cosine y all over. Now I got to choose this guy cautiously. So I'm going to pick the one that says 2 cosine squared minus 1. Oh, all right. So then that's going to be 2 sine cosine. The ones cancel out over 2 cosine squared. And then I can go like this, boom, boom, ba-boom. And then I can go like this, ba-boom, ba-boom. And then look what I got. Sine over cosine equals tangent, 3-dot, boom. And that's it. Okay, we are totally making this video obnoxiously long. Sorry, but we have to. We're at 13 minutes. The quiz totally is tomorrow. Let's review one more time what we have to know for the quiz, which is tomorrow. Open notes. Here we go. So our 3-3-3-4 quiz is tomorrow. I'll collect some homework tomorrow before the quiz, maybe after the quiz. I don't know. We'll find out. All right. So what could be on the quiz tomorrow? I don't know. Let's see. I guess all of this stuff right here. Are you ready? Awesome. All right. If A equals 60 and B equals 90, show that this doesn't equal that. Oh, okay. Note card. Sweet. All right. So 60 plus 90 is 150. So what's the cosine of 150 on my note card? Well, the cosine of 150 on my note card is negative square root of 3 over 2. Okay, and so I'm going to show that that doesn't equal the cosine of 60 plus the cosine of 90. All right, so that means the cosine of 60, I look that puppy up, that's 1/2. And then I look up the cosine of 90, well, that's 0. And obviously this doesn't equal that. Proven. Next, I'm going to move on. You're going to press pause. All right, next. If angle A is 2 pi over 3 and B is pi over 6, show that this does work. Oh, okay. So switch this first. You have your note card now, so, or your sheet. 2 pi over 3, that's 120. Pi over 6, that is, what, 30? Okay, so basically we're saying show that the cosine of 150 equals this mess. All right, so the cosine of 150, looking on my note card, negative square root of 3 over 2. Ooh, that's going to be a tough one to prove, isn't it? I don't know. All right, so this is 120. This is 30. This is 120. This is 30. All right, so the cosine of 120 is negative a half. The cosine of 30 is square root of 3 over 2. The sine of 120 is square root of 3 over 2. The sine of 30 is 1/2. Ooh, they look kind of similar, don't they? Well, let's find out. This is negative square root of 3 over 4 minus square root of 3, hello, over 4, which is negative 2 square root of 3 over 4. But those reduce, and oh my goodness, I just proved it. The 3 dot, boom. All right, I'm moving on. You're pressing pause right now. Hey, can you prove that the secant of theta minus 90 equals the cosecant? I don't know. Can you? I don't know. Could I? Okay. Yeah, probably. But you're thinking, dang, there's not a property for secant. No, but there is for cosine. So cosine of theta minus 90. If I do the cosine of theta minus 90, then we might be able to do a little trickaroo at the end there. Let's find out. Okay, according to the chart, it is cosine theta cosine 90 plus sine theta sine 90. Okay, so this stays cosine theta, but then I got to look on my note card. Hey, what's the cosine of 90? I think it's 0. Then this stays sine theta. Hey, what's the sine of 90? I think it's 1. Okay, so this really just equals the sine of theta. But that's what the cosine of theta minus 90 is. So the secant of theta minus 90 would be 1 over sine theta. But oh my goodness, that's cosecant theta. 3 dot, boom. That was me clearing my throat because I'm talking too much today, but we had to cover a lot. Let's continue. I'm moving on. You're pressing pause. Find the exact value of cosine of 15. Well, that's the cosine of 45 minus 30 on our note card. So according to the chart, that's cosine 45 cosine 30 plus sine 45 sine 30. So that's the square root of 2 over 2. Hey, didn't we just do the... No, we didn't. That's the square root of 3 over 2. That's the square root of 2 over 2. And that's 1/2. So that's the square root of 6 over 4. We've done this problem 1 million times now, by the way. Whoa. Square root of 2 over 4. But that's the square root of 6 plus the square root of 2 all over quattro. Done. That's not a proof. No 3 dots. No boom. I'm moving on. You're pressing pause right now. How about the tangent of 15? Okay, so I could do the tangent of 15 in a couple different ways. I guess we'll just do tangent 45 minus 30. Now, some people might just do sine over cosine, which is fine, I guess. Or you could try to use the tangent property. Let's go ahead and try to do the tangent property. Tangent 45 minus tangent 30 all over 1 plus tangent 45 tangent 30. Okay, so tangent 45 is 1. Tangent 30 is square root of 3 over 3. So then I'm going to combine. I'm just turning this into 3 over 3, and I'm turning that into 3 over 3. Handwriting's looking awesome. The 3's cancel out, and it's 3 minus root 3 over 3 plus root 3. Voila. Oh, no 3 dots. Almost put it there. All right. So that's cool. Didn't we already do this problem? Secant is 4 in quadrant 1. Secant is 4 in quadrant 1. Secant is flip a cosine, so it's a heap. So it's heap A. Heap A. So the hypotenuse is 4. The adjacent is 1. And it's in quadrant 1. So it's going to be 1 squared plus, I don't know, squared equals 4 squared. 16 minus 1 is 15. This guy's going to the right, so it's positive. And then you could totally do sine 2a, cosine 2a, tangent 2a. Do you remember that? Because we just went through it on homework. So sine 2a would be 2 sine cosine. Wait a second. Wait a second. Wait a second. Did I label this wrong? What? Yeah, that's cool, right? So sine is that. Cosine is that. Silly goose. 16, but then that 2 is going to make that an 8. So is that the square root of 15 over 8? Then cosine 2a, I'll do 2 cosine squared minus 1. 2 cosine squared minus 1. So that'll be 2 over 16, which is 1/8 minus 8/8, which is negative 7/8. And then the tangent of 2a is square root of 15 over negative 7. Adjacent hypotenuse. Here's the angle right there. Silly goose. I put the 1 in the wrong spot. It looks good. I'm moving on. You're pressing pause right now. Oh, we already did that one. So don't worry about that one. And that's it. Okay, so that's what's on the quiz. The quiz is tomorrow. Probably collecting homework. This video went on way too long, 25 minutes. Oh my snap. I will talk to all of you later. It is now 7 a.m. That's awesome. Good day.